Good day and welcome. Today we will be looking at how to plot and to graph a third degree polynomial. At this juncture, you should be very familiar with functions and how to generate a table of values in order to plot these values on a graph. When we look at the function of a third degree polynomial, we generally have the formula y is equal to ax cubed plus bx squared plus cx plus d, and we know that a cannot be equal to 0 because it must have a third degree. In a third degree function, I will have a maximum of one maximum value or one and one minimum value. But a function can also exist if a is positive that it does not have a minimum or maximum value, that it only has a point of inflection. If you look at the function where a is less than 0, meaning negative, the function will start at the top, move down to a minimum value, and then move up to a maximum value, and it will proceed to go down from that point. So the function could have two turning points or stationary points as we call them, but the function can also exist with no turning point but with a point of inflection. So let's look at the information. Firstly, we will determine the y-intercept by making x equal to 0. So that will be 0, that will be 0, that will be 0. So D will indicate to me what my y-intercept will be. If there's no D value, then that function passes the y-axis at 0 and 0. It passes through the origin. Secondly, for the x-intercepts, I will make y equal to 0 and solve for x by factorizing first and then calculating the values of x. What does these two mean to me? The y-intercept is where the graph cuts the y-axis. The x-intercept is where the graph cuts the x-axis. So these values are calculated by solving x. Once I have calculated the x and the y-intercepts, I need to calculate the stationary points. Now, for a cubic function, there will be two local stationary points. Cubic graph shows a local maximum and a local minimum. This can also be referred to a relative maximum or a relative minimum. So we find the derivative of the function. Once we found the derivative, we equate the derivative to 0 and we solve for x. Now once that was done, this will give me the x coordinate of the turning points. It will give me the x coordinate. In order to find the corresponding y value at that point and at that point, I need to substitute this x value and this x value into the original function in order to find the corresponding y value on the function. So just to point it out, we find the corresponding y values of the stationary points by substituting our x values that we found for the derivative that we equated to 0 in y is equal to the function, into the original function. Remember that some cubic graphs do not have turning points, but only a point of inflection as indicated in the previous slide. There's only a point of inflection and no turning point. to find the x value of the point of inflection, I will have to find f double dash of x. Meaning, I've got to find the derivative of the derivative of the function. And I must equate that to 0 and solve for x. Then I have my x value. Then I must take that x value and substitute it into the original function in order to find the corresponding y value for the point of inflection on the graph. So for those who do not know or understand the point of inflection, the point of inflection is where the gradient of the tangent to the graph will start changing direction. Now we get to how to determine the nature of the stationary points by using a table. Here we have a table that indicates the one x value of the turning point and the second x value of the turning point. So here we will take what happens to the left of that x value. Any x value to the left of it. Here we say any x value that lies between these two stationary point x values. And on the right of the second x value, give 1 point to the right of that value. Now, if the derivative of the function is greater than 0, then, meaning 1, 2, 3, or any positive value, the gradient is positive. Means the function is increasing. And when we say the function is increasing, it means from left to right, what is happening to the function? The function is increasing. If the derivative of the function is less than 0, meaning negative, then it means the function is decreasing from left to right. Now you can also say, what happens to this function as it approaches negative infinity? What's going to happen with this function? What is going to happen with this function as it increases positive infinity? The same with this one. What happens when it approaches negative infinity? What happens if this thing approaches positive infinity for a positive or a negative graph? And I think this answer we can already give without having to open our eyes. We can visualize what is happening with the function as it increases positive or negative infinity. To make an example, as it approaches negative infinity, this becomes extremely large positive number. As the graph approaches negative infinity, this one positive infinity, this one will be extremely large but a negative answer. I want to thank you for watching this video. In our next video, we will be looking at sketching the actual function and the process and protocols that we follow in order to get to the conclusion. Thank you for watching and goodbye.